Welcome everybody in AP Chemistry series. Today we'll start with section 8.2, which is all about the pH and pOH of strong acids and bases. Generally, before we start doing the calculation part, which is very easy though, we have to define what is the strong acid. The strong acid is a substance that dissociates fully in water and produces hydronium ion, which is H3O plus. Okay, so once we say it dissociates fully in water, it means this is a strong acid. The next question is, can you just give me an example of a strong acid? In your AP exams, you should memorize the strong acids. This will help you to do so many calculations successfully. So one of the main famous strong acids in your life, hydrochloric acid, which is the stomach acid. We have another acid, which is HBr, another one, which is HI. We have nitric acid, HNO3. We have sulfuric acid. And finally, we have perchloric acid, which is HClO4. So these are the main acids that you should memorize in your level. Now, my question is, how can I calculate the pH of a strong acid? How can I do it? If we put HCl in water, it will start to dissociate and gives you like the conjugate base in addition to H3O plus. And we can see like since we have a production of H3O plus, then this is acidic for sure. We have one arrow that goes to the forward direction. The presence of a single arrow tells me that the reaction is favored to the forward direction. All right, so for example, what's going to be the pH of a concentration of 0.5 molar of HCl? How can I calculate the pH? So first of all, we have to apply the Rice table. Since we have reaction in here, this is at initial. The concentration of HCl is 0.5 at time 0, for example, like our initial time is going to be 0 for both products. And here we have a change. Since we're talking about a complete dissociation, then I have to say 0.5 will be subtracted from here. All right, and we don't care about water so far. On the other hand, we have to add it to the part of a product, so we have to see 0.5 and 0.5. And just keep in mind, the HCl will be no longer in the solution as it completely dissociated, and that's why it will disappear as a concentration of 0. And here we got 0.5 and 0.5. Now, our target is to calculate the pH of this strong acid. So as we just remember from the previous video, if you want to calculate the pH, we have to say the pH is equal to negative log the concentration of H3O plus. All right. What is the concentration of H3O plus? It's equal to negative log. The concentration is equal to 0.5. So we put it 0.5. And if you do that in your calculator, you will end up with a 0.3. 0. What does this pH tell you? It tells you that this is very acidic. So like 0.3 is a very low pH, which means it's very acidic, and the small value reflects how much H3O plus you have. So if you just remember, if we are increasing the concentration of H3O plus, the pH will decrease. Okay, in order to describe the strength of acidity or the strength of the acid, we have to look at a factor of Ka, and Ka represents the acid dissociation constant. For example, if we have HCl, it dissociate in water, gives you Cl negative plus H3O plus. And I just need to write the Ka. It's the same thing if you just remember from Unit 7, we usually put the products over reactants, later concentrations, especially if they're in aqueous or in gaseous state. Since we have aqueous, and here it's aqueous, water is in a liquid state, we don't care about it, and here it's in aqueous. Then you have to say it's the concentration of Cl negative multiplied by the concentration of H3O plus over the concentration of HCl. And you can see that what is the relationship between the value of Ka and the strength of the acid. For example, if you look at the table in here, you can see that we have an acid of hydroiodic acid. It has a value of Ka, which is 3.16 times 10 to the power 9. And you can see this value is very huge. This is very big. And if you just remember from unit 7, as we have very high value of K, it means that the reaction goes to completion, and that's why it's represented in one arrow, because the forward reaction is way favored than the backward reaction. And this is an evidence that HCl here is dissociating fully or completely. All right. The same thing here is repeated for bases. If you have Ka for acid, then you have Kb for bases, and it's the same thing. What we conclude is as the value of Ka increases, the strength of the acid will increase. And we can see that we have another value, which is pKa. So what is pKa? If you just take the negative log of the Ka, you will have the pKa. And you just notice something. I'm going to erase the stuff in here. As we increasing the value of Ka, the value of pKa decreases because you take negative log, and this negative actually leads to decrease the value. So any acid with a value of negative pKa or low value of pKa, then it tells me this is a very strong acid. So in the first example of acid, the pH of 0 0.5 molar of HCl was like 0 0.3, if you just remember. Okay, but I have a question. Will the pH change as we add water? Like if we add water, what will happen to the pH? Does it remain the same or does it change? So we can prove that. I just want to give an example. Like suppose that we talk, let's say, milliliter of 0 0.5 of HCl. Okay. And then we made a solution up to 100 milliliter by adding water, like or distilled water. What will be the pH of this solution? Only thing that you should keep in mind at that moment that we made the dilution process. So which means we adding water. So since we're adding two volumes, like this is 100 milliliter, we have like 90 milliliters of water were added until like we have a total volume of 100 milliliter. Then we have to use the vom thing. Vom. Okay. What was the initial volume of acid? It was 10 milliliters. We multiply by the initial concentration of acid, which is 0 0.5, and the total volume is 100, and we have the M2, which is unknown. I don't know the new molarity after dilution of the acid. So you divide over 100 and divide over 100. And then the molarity of acid is equal to 0.05 molar. Here we have the HCl, dissociate in water to give Cl negative plus H3O plus, and the initial concentration of HCl becomes 0.05. We don't care about water, these are zeros. So since it's a strong acid, it will dissociate fully in water. Negative 0.05 plus 0.05 plus 0.05. And since we like completely delete the amount of HCl, if you want to calculate the pH, I have to say the pH is equal to negative log the concentration of 0.05, and you will end up with another pH, which is 1.3. We can conclude something like if we make dilution of an acid, the pH of acid will increase and it becomes less acidic. All right, since we covered the strong acids and their ability to dissociate completely in water, it's time to talk about the strong bases. So the strong base has the same definition. It's a substance that dissociate fully or completely in water, in addition to producing the ions of hydroxide. We have so many strong bases, by the way. So the main examples that you should keep in mind, group 1 elements, hydroxide, for example, if you have lithium hydroxide, sodium hydroxide, yeah, like generally the group 1 elements, they are good and strong bases, in addition to strontium hydroxide, barium hydroxide, SrOH by 2, or for barium hydroxide, BaOH by 2. So you should memorize all of these bases and just keep them in your mind in order to do them. Now, my question, how can I calculate the pH of a strong base? How can I do it? Let's take an example. If we have, let's say, NaOH, the most famous bases, if you just put it in water, it will start to dissociate to give you Na positive and OH negative. Suppose that sodium hydroxide has a concentration of 0.5 molar, and this is for the initial. They have initial like values for hydroxide and Na positive. And as we said, it completely dissociates in water. So we have to say negative 0.5. And the other hand, we're adding 0.5 and plus 0.5. And you can see that the remaining particles or the remaining NaOH is zero because, as we said, it completely dissociates, nothing left behind. So if I need to calculate the pH, what should I do? We just noticed that if you want to calculate the pH, you should say it's negative log the concentration of H3O plus, but you don't have H3O plus so far. What you have actually is the concentration of hydroxide. So that's very easy. We can calculate the pOH first, and we can say negative log 0.5, and as we said, it's equal to 0.30. So suppose that the temperature here is done at 25 degrees Celsius. So we can say that 14 minus 0.3 and equals to 13.7. This is the pH. And we can see that the 13.7 is a great pH. Okay, and actually it's reflecting the theory that this is a strong base. Okay, so you just remember that if you have a strong base, then it has high pH. Now let's start with a question. What is the pH of 0.5 of barium hydroxide by 2? So first of all, we have to write the dissociation equation, which is BaOH by 2. It will start to dissociate. It gives Ba2 positive in addition to 2OH negative. And if we apply the Rice table, this is reaction. The initial is 0.5, it's 0, 0. The change, we have to subtract 0.5, have to add 0.5, we add 0.5. All right, so it becomes, at equilibrium, it becomes 0. Here we have 0.5. And here we have 0.5, but we have to keep in mind that we have 2 hydroxides, which means that I have to add another step by multiplying this by 2, okay, as we can see. So first of all, you just notice that the concentration of OH negative is equal to 0.5 multiplied by 2, and it's equal to 1. All right, since we're given the OH, you have to calculate the pOH first, and it's equal to negative log the concentration of OH, which is 1 molar. The negative log 1 is equal to 0. So the pOH is equal to 0. Then the pH is equal to 14 minus 0. Then the pH is equal to 14. And we can say that this is a very strong base. You have to be aware of the stoichiometry of acids and bases. And that's it.